Hey guys, happy Wednesday. We're going to do 9.3 notes, and this is about polar and rectangular forms of equations. So rectangular form y equals mx plus b. And then of course our polar forms that are r equals maybe sine theta. That would be an example of polar form. So we're just going to learn how to go back and forth between the two. So we're going to convert between polar and rectangulars and polar to rectangular equations. So the first one here, it talks about the coordinates, and we're given some equations that we can use to go back and forth between the two. We know that x is equal to r cosine theta, and y is equal to r sine theta. And so basically this is our equivalent to our rectangular coordinates. Now for the rectangular, we have x and y. We'll have a point xy. And for polar, we have r theta, so keep that in mind. For the first one, we're going to go from polar to rectangular. So polar, and then we're going to go to rectangular. So we'll start out with that. I first have a polar coordinate, 4, and then pi over 6. So remember that's in the form r theta. So r is equal to 4, and theta is equal to pi over 6. So if I want to change it to a rectangular coordinate, and I know that x is equal to r cosine theta, then to find x, I'm going to substitute my r, which is 4, and theta, which is pi over 6, into the equation. And so that's going to be x equals 4 cosine of pi over 6. And cosine of pi over 6 is square root of 3 over 2. And so that tells me that x equals 2 square root of 3. Then for the y coordinate, I have r sine theta, y equals r sine theta. And when I substitute 4 in for r and pi over 6 in for theta, that's 4 times 1/2, which is equal to 2. So the coordinates, the rectangular coordinates, are 2 square root of 3, 2. And so that's my ordered pair. All right, so what do I do if I want to go from rectangular to polar? Well, I'm given another set of equations. To find r in my polar equation, I'm going to take the square root of x squared plus y squared, so you might remember that from the unit circle. And then to find theta, I have to look at a couple of different situations. One being, what if the x that we're given in our rectangular coordinate is greater than 0? Then theta is going to be the inverse tangent of y over x. If the x in the rectangular is less than 0, we're going to take the inverse tangent of y over x plus pi, or you could do plus 180, whichever you prefer, whether you're going to go in radians or degrees. So it says find 2 pairs of polar coordinates for each point with the given rectangular coordinate. So I know that x is 1 and y is negative square root of 3. Since x is greater than 0, when I go to find theta, I'm going to just use the tan inverse of y over x. I always want to check and make sure what x is, because I've got 2 different possibilities for equations. And then my r is the square root of x squared plus y squared. So we'll do a little substituting there to find the r. 1 squared plus negative square root of 3 squared. So that's 1 plus 3, which is square root of 4. So r is 2 in my polar equation. And then for theta, I'm going to do the inverse tan of negative square root of 3 over 1. And if you use your calculator, if you put it in degrees, it's probably a little bit easier because it's just mentally it's easier to transfer that. So put your calculator in degree mode, and I'm going to do inverse tan of negative square root of 3. And I get negative 60 degrees. So theta is negative 60 degrees. So I can leave it like that. You can put it in positive form either way you want to do that. So my polar coordinate is 2, negative 60 degrees. All right, so how about equations? Well, from the point, we knew it said that x is equal to r cosine theta and y is equal to r sine theta. So we're going to use that same idea here. It says to convert a rectangular equation to a polar equation, replace x with r cosine theta and replace r with r sine theta. So we're going to go from rectangular to polar on this one. And then in a minute here, we'll go from polar to rectangular. For this particular question, it says identify the graph of each rectangular equation, then write the equation in polar form. Support our answer by graphing the polar from the equation. So based on just what it looks like, this should be a circle, okay? With center 4, 0, and radius 4, because we're going to take the square root of 16 there. So if I were to graph it on a rectangular coordinate plane, here's my 4, 0, and my radius of 4 means that I'm going to go up, down, left, right 4 units. And so you can see, well, not drawn perfectly, it should be a circle there. So when we graph this on the polar coordinate system, it should look the same. I'm going to go down here and we'll do a little replacing. So I had x minus 4 squared plus y squared equals 16. And we're going to substitute, we're going to replace x with r cosine theta. And we're going to place y with r sine theta right into this rectangular equation. So I'll have r cosine theta minus 4 squared plus r sine theta squared equals 16. And for this first one here, this first term, it's a binomial squared, so you have to FOIL, and we would have r squared cosine squared theta minus 8 r cosine theta plus 16. And then for the second term, we'll just have plus r squared sine squared theta equals 16. Now I'm hoping that you're already thinking, oh, I've got a cosine squared and I've got a sine squared here, and it should start to kind of get you thinking about identities, in particular the Pythagorean identities. So I'm going to take the ones with the sine and cosine and I'm going to put those together, or just put them next to each other, so that I have r squared cosine squared theta plus r squared sine squared theta, and then minus 8r cosine plus 16 equals 16. Okay, so when I take out, I'm going to factor out in this first group an r squared. It gives me cosine squared theta plus sine squared theta. Well, if you remember the Pythagorean identity, sine squared plus cosine squared equals 1. So we know that this is equal to 1 right here, this guy. And r squared times 1 is just r squared. So now I have r squared minus 8r cosine theta plus 16 equals 16. And we're going to subtract 16 from both sides. And now I get r squared minus 8r cosine theta equals 0. I tried to insert a blank page. We'll see what happens here. That did not happen. We'll try it again. That's funny. I think I have it figured out now, as far as adding the page. So we know that cosine squared plus sine squared equals 1, which gives me r squared minus 8r cosine theta plus 16 equals 16, and then we're going to subtract 16, which gives me r squared minus 8r cosine theta equals 0. And so this is just like if we had any other polynomial, we would try to factor it first. So I have two terms here. I'm going to factor out an r, and that gives me r minus 8 cosine theta equals 0, and then set each factor equal to 0. So r equals 0 and r minus 8 cosine theta equals 0. And so r equals 8 cosine theta. Well, if I have r equals 0, that means a circle with radius 0, which doesn't exist, right? It's a nothing. So we can't have that, but we can have this, which is a polar equation. So our polar equation is r equals 8 cosine theta, which, because it has a cosine theta, it has theta equals 0 degree symmetry. And it has a max of 8, okay? A maximum of 8. Where would it have its zeros? Well, it would have its zeros where theta is equal to pi over 2 and 3 pi over 2, because that's cosine of 0 there. And it's going to have its maxes of 8 at 0 degrees, and then actually negative 8, which is going the opposite direction, at pi, which should end up being the same value. So let's take a look at that. We've got our, go back up here to our graph. So I have at 0 degrees, I have a max of 8. If I go over to pi over 2, I'm back at 0. At pi, it's negative 1 times 8, which is negative 8, which would put me back at 0. So I kind of need some in-between points here. So I'm going to do, I'm going to look at where cosine is 1/2. Cosine is 1/2 at pi over 3, because 1/2 of 8 is 4. So at pi over 3, I'm going to go out to 4. And that just looks off a little bit. Let me see that.